It's okay. Start.
I decided to do a game camera. My name is Brett Lachey, and this is the spring semester of 27-20. And I call it the Antler Finder 1.0. Little background. I chose to do the trail camera because I don't really have too many other hobbies except for maybe hunting. And it seemed like a good idea at the time because I had all the parts, the basic parts to assemble it and make it. Basically the whole design behind the camera is just to take pictures in the woods so you don't have to be there, you don't disturb the wildlife and the deer and their habitat. And I wanted to make sure it had a good battery life, so I put a big fat battery in it so it'll last for months and I don't have to worry about things dying or being worthless out in the woods. This is a system diagram that I drew. This is the motion sensor. It has a 5 to 7 meter range, so when it detects a deer or something out, it'll trigger the camera and it'll trigger the infrared. And the infrared will light up and flood the whole area with infrared light if it's at night. And then the camera will take the picture, and I'll have night pictures, or I can have daytime pictures because there's a cadmium sulfide cell inside the infrared, so it'll only turn on when it's dark out, even if it gets power turned on to it. This is my electrical diagram. It all starts at the battery, and then branches off. One leg will go to the switch, the other leg goes to the buck regulator. The buck regulator powers the camera only because it takes the 6 volts from the battery down to the 3.3 for the camera. The switch powers the boost regulator that powers the LED array and the microcontroller. And the microcontroller communicates to turn on the camera and take a picture with the camera. It also communicates back and forth with the motion sensor. The boost regulator only gets turned on by the microcontroller. There's an enable pin on it that I cut out and bent the lead up and hardwired it into my board that I added onto it. This is my schematic. I have 3 relays. I was trying to determine what I was going to use for the actual triggering of everything, and I decided to use relays because they're all hard contact. You don't have to worry about what's going to ground and what isn't going to ground, so I just made sure that I used relays for all my connections for the camera and turn them on with NPN transistors. I have one push button that I'm going to use for a setup mode, where if you press and release the button, it just turns the camera on, so you can play with the camera settings, and then press the button again and it'll take you out of that and back into the regular operating. And the switch will just turn off the micro and everything else except for the power to the camera, because I want to make sure the camera always has power so it remembers the time and the date and everything else that's in it, like the settings and stuff. This is a add-on board layout. This is my main board, and there's spots here for 2 separate add-on boards, one for my buck circuit and one for my boost circuit. These are where my relays would go, and my 14 pinouts. They go to the ribbon cable to my infrared, not my infrared, my motion sensor and my camera. And this is where I'm going to wire out a switch to the case of my camera itself, so I can turn everything on and off without having to get in onto the board to touch the button. These are the schematics of my DC regulators. This is my DC buck regulator that takes the 6 volts down to 3.3 volts. And I managed to fit it on a really small card, maybe inch by inch and a half. And that's going to mount onto the previous board, face down with these 3 pins. And then this is a little add-on board that's going on to the buck boost converter that we got from Professor Correo. And I'm just going to mount this onto here in all 4 corners, and the enable pin goes down to these headers. And it's hardwired into the board. And And then this one will just do the same thing and plug down into my main board. That way I can replace them if they fail. My motion sensor is a 3.3 volt TTL output with a 5 to 20 volt input, and it has an adjustable trigger of 5 seconds to 18 minutes where it'll go high and signal the microcontroller to turn the camera on and take pictures and do whatever it has to do. And it has a really high operating temperature range of minus 15 C to 70 C, or 5 Fahrenheit to 158 Fahrenheit. Has a good, well, it's a good motion sensor. I like it. I think it's going to work good with my, it already has worked well in our testing. And I'm going to adjust it so it's about a 10-second delay, or about a 10-second time delay. That way everything has time to turn on before the signal gets lost or anything. Most of my calculations were done in our Armenian and Kazimierczuk electronics devices book, and that was for my buck regulator calculations. The calculation for the resistor before the transistors, my base resistors, was just the 3.3 volts that's going to be coming out of the micro to turn them on, divided by the I coil over beta of the transistors. I'm going to use 100 because that's the minimum beta for the 2N3904s. So I got about 8.3 k ohms. I'll probably just change it to a solid 8.5 when I put them in. Should work just fine. If that's a standard value. I haven't checked on that yet. These are some examples of my code that I'm going to use. On, off for my autofocuses. They're all the same pins. One's just high and one's just low. I'm basically going to have one big forever loop with multiple if statements inside. This if statement would be for the push button to set it into setup mode. And then all these others, if motion, it'll go into take a picture. And I have a void statement somewhere else in my code that goes into all the different steps for taking a picture with their time delays and everything. And down here at the end, if pix equals 6, it's going to take 6 consecutive pictures. And then once it hits 6 consecutive pictures, it's going to shut the camera off and delay for 2 minutes, I believe. That's what I set it for. That way it gives the chip time to cool down before it takes more pictures. And this is my finished product. The next step would be to add camouflage paint and mounting brackets to the back so it can be mounted to a tree. But as you can see, my infrared LED array, my motion sensor, and you can't see it, but the camera is in here and it's covered with a thin plastic clear sheet over that hole so that nothing can get into the case, and the camera can still take pictures, which was a lucky find for me to find that case that everything can mount into. These are my finished buck and boost regulators. This is the one that we were given, and this is the add-on board that I built for it. That way you can mount to it and have the 5 pin outs, and the middle one is the enable. The second one is the enable pin. It allows us to turn the buck boost on and off with the chip that's on it. And this is my finished buck converter, and I used the I can't remember the name of the chip, but I used a buck chip, and I was lucky to find this little trim pot so I could adjust the feedback and make the perfect 3.3 volts out. And it just comes into these 3 pins, and again it just plugs into the board and it can be replaced if it fries or if something goes bad. And the chip can also be replaced too if I do something to mess up the chip. And this is a previous result that I got with another game camera, which I'd like to capture with the one that I built. This was in our front yard up at our camp, which doesn't make me very happy. Some issues I ran into were how to power the game camera, because I had multiple voltages that I was going to need. The infrared was going to take 12 volts, my camera was going to take 3.3, and my micro could take 3.3. but I decided to just run everything off the 6-volt lead acid batteries that had been ordered, because they would work perfectly fine and they were rechargeable, so I wouldn't have to worry about replacing a bunch of batteries. I could just put it on a charger and charge it up. How to wire up my camera, which is the triggering method that I should choose. I ran into some issues with whether I should use relays or transistors. I found that one switch was not actually set to ground, so I couldn't use a transistor with that, and I had one other 2-stage button. The first stage was the autofocus and the second stage was the triggering. So I just decided to use relays for everything and just run everything where there was supposed to be, and I hardwired everything in with ribbon cable into my camera. I cut out the flash circuit because I wasn't going to be having the flash taking pictures out in the woods, scaring anything or making the camera case glow. The new board design was very clustered at first, but I figured out how to eliminate some of that by making the 2 add-on boards, the 2 regulators. That way they would stand vertically and I didn't have to make room for them on the flat, laid down big board. Some of my product impacts. Environmental are very low because the standby power is very, very minimal. So it won't be using too much voltage, and the batteries that are in it are rechargeable, so I wouldn't have to worry about disposing of old AA batteries or C batteries, whatever I would have ended up using if I hadn't used the 6-volt lead acid battery. Social, it allows hunters to better track their game locations and patterns, and they can boast about the deer that they have on their cameras to their buddies, give them something to talk about, feel proud of. Ethical, it allows you to collect information about the animals without constantly visiting their area and possibly disrupting their movements and patterns, which I think is a pretty big thing if you actually intend on going in and finding the deer and shooting one during the season. That's the end of my presentation. Anybody have any questions that I can answer? Windsor, you get a smile on your face.
Can you go back to the PIR motion detector slide? I don't know that one. Yeah, you mentioned the 10-second delay, but it wasn't clear to me, or I wasn't listening.
Yeah, 10 seconds. It's adjustable from 5 seconds to 18 minutes.
Okay.
There's a little trim.
You say, when you were saying that, you were saying something about so it could warm up. What was that? Was that the time before the motion detector?
No, I was just going to make sure that it was a long enough time delay high that everything had a chance to turn on. I guess it doesn't really matter as long as it triggers and it's a long enough trigger time that the micro will catch it, which it doesn't really have to be long at all.
Right.
It can be the minimum.
Okay. Yeah.
And everything will trigger.
Yeah, the micro will
turn
be on for the microsecond, so
yeah.
I didn't.
Just a short
I wasn't
burst.
sure what you were saying about the 10 second. If it needed to be at least 10 seconds.
No, that won't have anything to do with it. If it could be shorter than 5 seconds, it would still work fine. Less than a second would probably still work fine too.
And you say the whole thing is low powered. I probably should have asked this of the other people too, but has anybody sort of measured the total current this thing is going to take when it's running? Are you at that point?
Haven't yet.
Yeah.
I still haven't had I just barely got my board finished, and now I can get it soldered up and test all the currents going into it and everything.
Okay. Because it'd be good to have, certainly on your website, a list of specifications, what this thing actually accomplishes.
Yeah.
So I think the strategy to turn things on when they're needed and everything, that's going to help. And if we put the processor to sleep, that helps. All right. Any other questions? All right, thank you.